Hi everyone, and welcome back. So this week we're going to be talking about sensation and perception. We're going to move from the biological perspective into a sort of anatomical perspective. We're going to be talking about how we get all of this energy that surrounds us into our brains. How we change the energy of various types, whether it be vibratory energy or light energy, into chemical and electrical energy that our neurons can understand and that we interpret as conscious experience. We're going to talk about each of the major human senses, and animal senses really, in detail, but we're going to start with ocular anatomy. Okay, so the anatomy of the eye. We're going to talk about vision. And the reason that we're going to talk about vision is that humans are inherently visual creatures. If you ask samples of humans which sense they would least like to use, vision is almost always at the top. And the reason for that is that our brains are wired for vision. There's a phenomenon that we call attentional capture, that if you're hearing something and you're seeing something else at the same time, you pay less attention to what you're hearing than what you're seeing. The eye is also one of the best understood organs of sensation and perception, so we'll use the anatomy of the eye to help us understand the whole process of sensation and perception for all of the different senses. So I just want to talk a little bit about the eye and about why we're gonna focus on that. The eye is amazing. What it does is it takes light energy, photons, from the sun. So let's imagine, for instance, that you see your friend from across the parking lot there at MCC, and they're wearing a new bright blue t-shirt. Light energy from the sun, a photon, is striking that t-shirt and is bouncing off of that t-shirt right at your face. The eye allows you to capture that energy and interpret it as a blue t-shirt. That energy will pass through the cornea of your eye. Your iris will constrict to change the shape of the eye and the pupil so that that photon can pass right through the hole in the front of your eye. It'll move through the interocular fluid, and it'll move through the cells, the retinal ganglion cells and the blood vessels at the back of your eye that make up your retina, and it'll strike the fovea. It'll hit a cone there. It'll hit a blue type cone, and that photon, because of its particular wavelength of light, will trigger an excited reaction in a neuron, in a cone, there in the fovea. That neuron will fire, will be excited, just like we learned about in the last chapter, and produce an action potential. That action potential will stimulate nearby neurons and will cause the eye to shift focus, and in the end, that information will get passed up the chain through the brain, allowing you to interpret that photon as a blue shirt. Sensation, when we talk about sensation and perception, is the problem of those photons. The problem of getting that information through the process of what we call transduction and then transmission to the brain. Perception is how we manage to take those neural impulses, those electrical signals that are now happening, and turn it into a conscious experience of blueness. We're going to spend quite a bit of time at the end of the chapter talking about perception and perceptual errors. I hope you'll enjoy those, particularly the optical illusions are lots of fun, and you might consider going around the internet, finding some more, and posting them on the discussion board this week. I look forward to our discussions. Let me know, please, if you have any questions.